will record both days, obviously. So if you're not here, please try and watch. And this is our last set of FRQs. So this will be the third and final set. Our test is a week from today. So if FRQs are what you're most concerned about, if you go into modules in Canvas, you'll find a video of me doing all 3 sets of them, okay? So mock 1, mock 2, and before we did the first mock exam, we had a review packet, R1 to R7, if you remember, and the last 4 pages of that R1 to R7 was a set of FRQs. So we did those together. I did them on Canvas, mock 1, and now mock 2, we're calling this, okay? So lots of chances to get some practice. So guys, I know I had to fit like 4 of them on 1 sheet of paper, so save it for tomorrow and all that stuff. And I know it's really small, but I did post the full size like you see here and all the keys on Canvas. You can write on that, write on the sheet of paper or whatever. Just a chance for us to review, okay? All right, so FRQ 1 and 2, 15 minutes each, calculator active on both. And what's really nice about these two is I really feel like if you put the effort in and just especially learn a few key phrases, you guys can really get these 12 points, or at least the majority of them. You know, FRQ 3 and 4 were a little bit more realistic about, it's a little bit harder, and we'll talk more about that tomorrow again, about where you can like pinpoint some places where you know you could get some points, and then if you have time, go back and fight for the other ones. So FRQ 1, you're always going to be given 2 functions. Here it's a graph of f and then g of x, which is, it's hard to see, that's a cubic equation. And the other 2 FRQ 1s that we did together, you guys, this was a table of values and not a graph. So you're seeing another way you could have it look. A1 and 2 will always be the same questions, especially A1, I'm really sure of. And that is function h is defined by this composition. Find the value of h of 4. All that means, guys, is remember, anytime you see a number inside there, that's your input. You're going to be finding, I'm just going to use this space up here, h of 4, which is use either one of these. These are just compositions, so I'm going to use this one, and that's the input I'm using. I'm trying to find x is 4 into these 2 equations. It's always going to start like that. It may not be a 4, it could be any number, but it's going to be this type of problem. And so you're saying, okay, when x is 4 on the f, when x is 4 on the f function, what is y? So f of 4, so here's 4, y would be 2, right? F of 4 is 2. So I'm going to replace that with 2. So now I have to find g of 2. And so here we are. G of 2 is just plugging 2 in for x in the g function. And then after that, it's just putting it in your calculator, okay? So f of 4 was 2. G of 2, plugging 2 in, is negative 9.3. So just being able to plug in x, and if you want to take a second and make sure you can get that, but you need to be able to plug a number into your calculator, call calculator, not to do it by hand, and get that answer. Okay, so that's a point. We can all get that point. It's a calculator. Okay. And if anybody gets stuck and I move past it too fast, please let me know. When I'm done, I can answer some individual questions. I didn't get that. I had a problem putting it in my calculator. Whatever. Just remind yourself to ask me. Okay, because this won't take the whole period. Part 2, find all the values of x for which f of x equals 3, or indicate there are no values. So f of x, make sure you're looking at the right one. This is f of x. So when x is 3, no, sorry, I said that wrong, right? This is saying y is 3. Be careful. When y is 3, what is x? So y is 3 is right here. There happens to be 2 values, okay? So when f of x equals 3, x equals 5, and x equals 7. That's it. That's another point. That's just being able to read the graph. And what's good, guys, is remember, FRQ questions will be on your blue book on your screen. You'll be writing in a, you've seen this before. Always make sure you're on the right question, 1 at the top. But what they will do is reproduce, like if there's a graph that you could be writing on, it will be reproduced on your booklet so you can write on it and stuff like that. Like if this was a table of values, you'd see the table of values on here so you could write on it and stuff like that, okay? So 2 pretty easy points, all right? B1, find all real zeros of G as decimals, or say there are none, okay? Zeros. So this is where, guys, you would go to your calculator and type it in. Type in G. So G is this one. So that's 1.2. I would definitely recommend you guys typing these into your calculators. The more times you practice this, the quicker you will catch a mistake that you keep making or something. And I'm going to go ahead and graph it and see what it looks like. Okay, it's a cubic. It makes sense. Opposite end behavior. It's got 3 x-intercepts. Now, my calculator is a little bit clearer than those. These are the ones you'll be working with on the exam day. These are the ones I'll have ready for you on that day. And so on these calculators, it's a little easier to get on the left and the right of your zeros. But if you wanted to zoom in a little bit, I don't like using the zoom buttons. I feel like they're a little out of control. I don't know. Maybe you like zoom. You can do whatever you want. But when I look at this, I see a whole bunch of dead space right here. So I might change my window to like -5 to 5. And that just gives me a little bit of room on either side. You know what I mean? Like it just kind of zooms in nicely. And whenever we're asking for the zeros, it means the x-intercepts. So when we go to calculate, remember this is where min, max, intersect are. Be careful though, because a mistake I always see students make on this type of question is they think they're going to use intersect. Because technically the graph is intersecting the x-axis, but it has a more specific term, which is 0. So you would use 0, okay? And you have to find all 3 in any order, it doesn't matter. But remember, you're going to use your left and right arrows to get to the left. So hit enter whenever you're happy. To the left of your 0, move to the right, and then guess. And you can see when y is 0, x is -0.36. Round to 3 decimal places. And then you just have to do it 3 times in this case. Get to the left, right, enter. That's how I got 0.398. And then there's one more. Arrow all the way over, left, right, enter. Okay, so remember, we're always rounding to 3 decimal places. There's never a question about that. It's never going to tell you to round to 3 decimal places. We just know that. We've done it all year, and that's what we'll always do. Okay, so this is a place 1B, B1, that we have seen an alternate question. On the at least one of the other 2 FRQ ones we did, you could have seen what is that, like it'll just say this. So let's just talk about that real quick. This means inverse. It doesn't say what is the inverse. It just gives a symbol. We know that that means inverse. So instead of this being x, it is y. So what is x when y is 4 is what it's asking. So again, when y is 4, x is 6. Okay, so you could see that question there instead of finding the zeros. Okay, another easy point, especially if it's that one. All right, B2 is always going to ask about end behavior. Okay, end behavior of G is x decreases without bound. Express your answer using the notation of a limit. So we have to be good at being able to write a limit statement. Easy point, guys. You guys are fine with this. Let's just remember how to write it. LIM of who, it will tell you, G of x. You'll always have x approaching symbol. And then this will change from problem to problem. This one says decreases without bound, so we know that means negative infinity, and then equals. Well, we already put G of x in our calculator. We did it a second ago. It's right here. If you hadn't done it already, because maybe you had this as your last question, you wouldn't have typed that in already, you would type it in and just look at the graph. It's really easy to tell. As x goes towards negative infinity, our y's also go to negative infinity. Easy point, right? What we saw last summer, which I don't know if we'll see it this summer, because now that, like last year, we didn't know what the questions were. My students last year did not get all of this that you guys are getting, okay? This year, we know that this question is going to be this. But last year, we saw a lot of students giving both end limit statements because that's what you're used to. We would look at a polynomial and we do a left and a right limit statement. So just as a words for the wise, you're only going to be asked for one, only answer one. Why waste time doing more than what you have to do? Because here's the deal. If you erroneously read this and you think, oh, I'm going to do the right one, don't write it right now. So if you decide to do that and it's wrong and you get it wrong, then even though this one is right, it won't matter, okay? So let's not even gamble. Let's just answer the question they asked for and get that easy point, okay? It's only going to be one-sided that they asked for, all right? And C1, I loathe this question. This question is asking if there is an inverse function for this, and then why. This is saying yes or no for part one. That's how you get the point. And part two is a very, very, very specific reason why or why not. Okay? This question is what made me cry last summer. I'm not being dramatic. I literally cried a lot over this question because I was so frustrated with it, and I'm going to tell you why. But I also know exactly how you answer this question and get it right. Why haven't we seen this before? Because there is an alternate question you could get here that we've seen on the other two we did. I'm hoping, and I'll go over what that was real quick, I'm hoping this is the one we see this year because this is the one that was there last year, okay? This was last year's question, and they keep showing us other examples of question C being this question. So I'm hopeful that that's what we get, but we are going to be prepared either way. The alternate question, before I finish this one, is if you were given a table up here, it asks, is it linear, quadratic, exponential, or log? So you got a point for just answering that right. And then the second question would then describe why. And remember, there was like those really specific terms, consecutive, equal length intervals, and some other things they had to say that were very specific. Well, don't worry. We see these a lot in the multiple choice, and I'm hoping that we'll see it here too. And it's one of the things I'm going to go over with you guys as our last minute like brain dump Friday, Monday. I'm making you guys like a little, I'm going to type it out nicer than this, but I'm just kind of going through all the different things I want to remind you of last minute. And one of those things is the wording for those four. Okay, so we're going to go over that. And that's like the piece of paper you're going to walk around with until the test, and then you can see, okay, don't forget to do this, don't forget to do this. I'm keeping track of all those little last minute things, and that's one of them. Okay, back to this dumb question. What it's saying is this. Determine if an inverse of f, an inverse function of f. So here's f, okay? So back in Algebra 1, Algebra 2, you would be asked this question, is this a function? Is this a function? No, we already know it is. It's saying function f. We know this is a function. So let's review what that means. A function is no repeat x values. All the x values are different. You don't use any of them twice. It also passes a vertical line test, if you remember. What this question is asking, and let me just show you. I made a table of values of these points just to prove it to you. This is a table of value of all those points, okay? See how all the x values are different? That means, yes, this is a function, which it already said that. But the question is saying, if you do the inverse, is that a function, okay? And the answer is no, because you can see, even though there's no repeat x values, there's repeat what? Y values, which means the inverse of this, those y values would then be the x values, right? Here's the proof of that. If I took this table of values and flipped it, which is what the inverse would be, you can see a couple examples where we have repeat x's, okay? So what were y's here are now x's here. So the answer is no. The answer is no. You get a point for C1 saying no, the inverse is not a function. The hard part is this. To me, I don't know. My roommate last year, who was cuckoo, She thought it was hilarious that I was so confused by this. I was not the only one, okay, I will tell you that. But I find this wording to be very, very not clear, especially when you read 1,000 different ways students wrote this paragraph, okay? So this is the number one best way of saying it. So listen, it's not, okay? There's the model answer, but I graded this question last year. Yes or no gave you the point. So you can say yes or no, okay? 2 is this. Each output value of f. So we're talking about the function that you're looking at right now, what they gave us. Each output value of f is not mapped, connected to, from a unique input value. And you have to give an example for the point. If you don't give an example, you don't get the point. So if the answer is no, you're going to say this reason and the why not. If the answer was yes, you would say each output value of f is mapped from a unique input value. And you won't have an example to give because there are no examples. If it is, they're all different, okay? So this question is not my favorite. I'm praying we don't get it. Okay, maybe memorize it, tattoo it on your arm. Just kidding. Nope, I did not tell you to cheat. Okay, I hate this question. Okay, let's go on to question 2, and this is on Canvas 2. Let's go on to question 2. Second one, which I definitely think we can get a lot of points. In question 2, also calculator active, you will be given a word problem always, and sometimes they give you a table of values here, or they might just zero in on 2 ordered pairs. But whether it's a table of values or not, there's always going to be, even if there is a table of values, you're always going to be given 2 ordered pairs to focus on. Okay, and in this case, they didn't give us a whole table, but somewhere in the word problem, they gave us the 2 ordered pairs. So let me read. The Chinese bamboo tree exhibits a unique growth pattern. Once a seed has been planted, the Chinese bamboo tree does not break through the ground for several years, imagine. However, once it breaks through the ground, the Chinese bamboo tree grows exponentially. That means really fast, okay? In one particular experiment, a group of biologists recorded the height of a Chinese bamboo tree once it broke through the ground. So after 1 week, it grew 3 feet. After 5 weeks, it grew 89 feet. There's your 2 ordered pairs. It'll always be somewhere in the word problem. You want to identify those for sure. Okay, got 2 ordered pairs. And it will always give you a model. They're telling us exponentially, that is the model for it, okay? So A1 and A2, every single one of my students should get these, for sure. A1 is plug the ordered pairs into the model. That's it. So you guys, this is y equals a times b to the x, right? H of t is y, t is your x. Just plug the points in. Here they are. Y equals a times b to the x, and y equals y equals a times b to the x. So writing those 2 equations, that's a point. That's an easy point. Right? Just plugging in x and y from the ordered pairs that you were given. A2 is what is A and B. This is where you go to your stat, enter, and all of that stuff. You're always going to do that on this step. Always. And so we go stat, edit. Remember, your x values go here. Your y values go in L2, right? Stat calc, it told you it was exponential, so we have to find that. As a reminder, number 9 is ln. That's your log one. If you ever have to do a log one, it's always going to be natural log. That's the one you use. And exponential is right below it, for its letter number 0. Enter. Always store it. Alpha trace. Enter, enter, enter. And there's your A and your B rounded to 3 decimal places. Okay? That's another point that's easy to do. Now, one thing, everybody look. One thing I talked about last week, in case you weren't here or in case you were here and you missed it, either way, what do you do if instead of a times b to the x, they put a transformation in it, like a +1, and I showed, what? You have to do it here. Yes. Okay, I thought you were saying you couldn't see it, and I was like, oh, that's right, you can't. Oh, that's over here. So if it said the a plus, if you can look over there, +1, if they put that in there, we can't do a transformation model on our graphing calculators. This is when you have to use Desmos. You might want to use Desmos anyway. I think Desmos for this type of problem is pretty simple. Watch, when you open up Desmos, this is what you see. You click the plus button, and you find table, and there's your table. So I would type in 1 and 5 for my x's, and I'm just using my keyboard like you would, 3 and 89. There's the table, okay? And then once you put data in the table, this little symbol comes up. And what's nice is, like this calculator, there's a million things staring at you every time you look at it where you have to decide. There's not much that goes on in Desmos. There's not a lot of places you can click, so it would be hard for you to not figure out where to go. I'm sorry if you guys can't see. But if you hover over this weird symbol here, it says add regression, so click on it. And then you have a drop down of all the different types of regression. So for this one, we want exponential, and there's the A and the B that we just found, okay? But remember, what if it does have like some kind of transformation in it? Well, that's when you can click on these 3 buttons here. See how it says regression options? And you want to export as custom. You can't hurt anything, guys. If you hit the wrong button, all you have to do is hit this back arrow and it erases it, okay? So you're not going to mess anything up. Export as custom regression, and then I can type on this basic parent function and put in my transformation. And I like that we're doing this one, because if I try to put so if you guys, you may not be able to tell, but I do have my cursor up there with the exponent, but if I try to type, it always, oh, it did work. Oh, it worked. Okay. Sometimes it doesn't work. I feel like it doesn't work. And I have to put it in parentheses. So play with it. If for some reason you can't, like before I couldn't, I had to put it in parentheses to make it work. But anyway, that's how you would handle if, like last year, my students had a natural log with a +1 in it. They probably all got it wrong. We didn't have Desmos last year, and I didn't teach them how to do it algebraically. Or I think I did once, but we don't need to worry about that this year. Desmos is really easy. Okay? All right. So back to the problem. B1 is always going to be a rate of change problem. Use the given data to find the average rate of change from week 1 to week 5. Express your answer as a decimal and show the computations. You do not need to show this. I'm just reminding you, it's always change in y over change in x. Here's your computation. Second y minus the first y over second x minus the first x. That's your computation. That's it. Put it in your calculator and you will get 21.5. What is it? Feet per week. Remember, T is time in weeks, Y is height in feet. That's what's going to happen. Each week, on average, it will grow, the bamboo trees grow 21.5 feet. That's pretty fast. Okay? I wonder if it's true. All right, part B2, interpret the meaning. All right, and there's an alternative question that we could get, so I'll go over both of those. So here it is. So here is our answer for the change in y over change in x. That's a point. The fact that it said a decimal approximation means if you're so used to hitting math enter on these calculators and you change 21.5 to 43 over half, you will not get the point. If it tells you to leave it as a decimal, you have to leave it as a decimal. If you have to round it to 3 places. That one was not needed to be rounded. And so for part 2, if it asks to interpret it, you're basically just going to say in a full sentence what we just found. From week 1 to week 5, and we would want to reference that time, the bamboo tree grows 21.5 feet per week. Easy. Second point there. Let's talk about that alternate question, which I think you might see. I think this might be. I'm guessing, but I'm just going off of last year. Use the average rate of change that we just found, okay, to estimate the height of the Chinese bamboo tree at t equals 8. I meant to put weeks there, not years. Sorry, we're talking about weeks. I apologize. Show the computations that lead to your answer. So this is where you start with one of the ordered pairs. It really doesn't matter. Start with one of the ordered pairs they gave us. You can start with week 1, it was 3 feet, or week 5, it was 89 feet. I'm going to pick week 5. So at week 5, we were already at 89 feet. How can we figure out what it would be 8 weeks? Well, between 5 weeks and 8 weeks is how many weeks? 3, right? We want to know what happens in week 6, week 7, week 8. That will be how tall it is then. So that's 3 weeks times that slope. And you just put that in your calculator, right? So we already know how tall it is at week 5. Then in week 6, it went 21.5. Week 7, 21.5. It's just a shorter way than adding 21.5 3 times, right? Every week. This is really showing you understood what you found, okay? And it's like 153.5 feet. Okay, so that could be an alternate question. I feel like it could be that one, but who knows? All right, last 2 questions, also each worth a point. Consider the average rates of change from t equals 5 to t equals p. So p is what we don't know, but it's telling you p is greater than 5. So we know what happens from week 1 to week 5. We have real data from that. What happens after week 5? Okay, that's when our model comes in handy. The graph that we, the stuff that we just put in stat, calc, all that stuff. Remember how we saved it? That put it in y equals for us, which allowed us to graph it, look at the table, all that stuff. So it shouldn't be surprising that this is an exponential function. Okay, of course it is. It told us it was going to be that. And it's showing growth, right? It's increasing, and it is concave up. So what we could assume is that as time goes on, right, after 5 weeks, anything greater than 5 weeks, the growth is going to keep growing at an increasing rate. Here's your model statement. The average rates of change of h from t equals 5 to t equals p weeks are greater than the average rate of change from t equals 1 to t equals 5. Why? Because h has exponential growth, and here are the words we're really looking for in this question. You want to say whether the graph is concave up or concave down, okay? And is the rate of change increasing or decreasing? That's what they're looking for in this question. Rate of change and how it relates to the concavity. So remember, the little trick is concave down, rate of change is decreasing. I mean, you're not using the word it, you're always referencing to whatever we're talking about, h. Not it is increasing, the rate of change is increasing. Okay. And our last question, for which t-value, t equals 4 or t equals 11, should the biologist have more confidence in when using this model? Give a reason for your answer in the context of the problem. So what they're saying is, should we trust in our model? So here's our model, guys. This is what the model is. You can go to the table, and you can make a prediction for any week, right? 1, 2, 3, 4, 5, which we should have a lot of confidence in, right? 1 through 5 is where the data really happen. But you could go and look at, 105 weeks, 2,000,005. You have a table of values that's going to make predictions for you. But that's all they are. So you're always going to pick the value that's within your data. 1 to 5 is where 4 would be. So we should have more confidence in that. We can make a good estimate about what happens at week 11, but could a plague of locusts come in and kill all of the bamboo in 10 weeks, or a tsunami come in and knock out all of the bamboo or something? Like, we don't really know what happens, but we're just saying, as mathematicians, we can give you our best estimate of what will happen. But we do have a lot of confidence in our model for week 4, because that's when something really happened that we have true data about. So model answer here, these FRQs, I know you guys have a lot going on, but we're going to be point hogs you want to try for every point. And when we know what the questions are, and I tell you some keywords, it really is worth it for you guys to just kind of memorize certain phrases and words. And I know when it says that, she always wants us to say this. Oh, don't write it as a decimal. She said, be sure you write this as a decimal, or as a decimal, not a fraction, or whatever it may be. Because you guys, this is your AP exam that you can get a really high score. You really, really can, okay? Especially on FRQ 1 and FRQ 2. Now, last few things I want to say. When you take this AP exam and you're doing your FRQs, if you don't finish your thought, like on this question, like you didn't get to finish it, or you think about it later and you're like, ooh, I didn't want to say that. I forgot to mention outputs, or I don't know, whatever it may be. Remember, you always have the booklet in front of you. You won't see the questions anymore once you're in FRQ 3 and 4. But if you have a lot more confidence in your question 1 and 2, and you're like, oh, I'm going to use some of my 3 and 4 time to go back and fix a sentence or finish a thought, do that, okay? I want you guys to have a lot of confidence in 1 and 2. Tomorrow we'll talk about 3 and 4 and where we're going to do them all, do it all, but where can you really skip to if you're worried about time and if you're not really confident. A couple more things. One thing we do advise you guys, and we haven't talked about this ever, is not to circle answers, okay? So let's pretend, so listen, you're allowed to circle your answer. So FRQ4, you do all these steps and you're like, oh, here's my answer, let me circle it. You're allowed to. But when you circle something, you're telling the grader, focus on this. If I circle this, that's very clearly me telling you that's my answer. If you don't circle it and I see the answer there, I can still give you the point. Meaning, what if you went too far? What if this was the actual answer? What if that's where I wanted you to stop? If you didn't circle anything, even though you went too far, the grader gives you the point, okay? So it's better to not circle. Also, it's better not to go beyond the borders because these get scanned, and when we grade them, we don't have a hard copy in our hand to like see. It's scanned into this program, and I'm using my computer to read it and grade it. So if you are in those boundaries, they cannot guarantee the scanner will pick it up, okay? So you want to try your best to stay in the boundary, okay? You are allowed to use pen or pencil. Doesn't matter. Blue ink, black ink, or pencil. But do not use a mechanical pencil. They don't show up, all right? And if you are a pencil writer, like we're math teachers, we tell you to use pencil so you can erase. But as long as you aren't writing really light. I've seen some of you, it's hard to grade your tests and stuff because you're such soft writers. You want to make sure your writing gets picked up by the scanner. So if you're comfortable using pen, maybe that's better. Decide for you. Okay? Here's where my gift comes in. So if you're watching this video because you weren't in class, you need to see me so you